Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problem 37 of the June 2015 Algebra I Common Core New York Regents exam. All right, problem 37 reads, a football player attempts to kick a football over a goalpost. The path of the football can be modeled by the function h of x equals -1 over 225x squared plus 2/3 x, where x is the horizontal distance from the kick, and h of x is the height of the football above the ground, when both are measured in feet. First question, on the set of axes below, graph the function y equals h of x over the interval 0 less than or equal to x less than or equal to 150. Now this is a very calculator heavy problem. We're going to be relying heavily on our graphing calculator to solve this problem. So let's go ahead and take a look at it. I will be using the TI-83 plus calculator. The syntax is very similar to other Texas Instruments calculators. So to graph the function, I'm going to generate a table and a graph in my graphing calculator, and then I'll use that to generate a graph here also. So let's go ahead and enter the function. Negative, note, I am not using minus, I'm using negative, okay? So use negative here, negative, parenthesis, 1 divided by 225 x squared plus 2 over 3 x. Oh, gotta close that parenthesis. 2 over 3x. Enter. All right, so let's graph it. Okay, so that's what a standard graphing window looks like, okay? But we're going from 0 all the way to 150. So how should we set up our graph? Obviously, we should go from 0 and end in 150 for our x window, okay? So what we're going to do, just to give you what the graph looks like, we're going to press window, and we have a whole bunch of options here. Now the x minimum here is 0, enter. The x maximum is 150. Now what's the scale? How should we scale our x-axis? By what factors? Well, let's take a look at this graph, the grid we're given here. Since this is what we're graphing it on, it's good to make sure we take into consideration the format of this grid when we're using our calculator, okay? If you count these tick marks on the x-axis, there are a total of 30. Okay, there are 30 tick marks here. So we can let each tick mark, let's do the calculation here. So if there are a total of 30 tick marks, and you have 150 in all, so what is 150 divided by 30? If you divide it, you end up with 5. So we can scale it by 5. So each tick mark here will be 5. Let's go ahead and put that in our calculator. So we have, let's scale it by 5. Now the y, we know that the y goes as low as what? 0. It doesn't go below 0. So the x mean is 0. Now x max, now this is a complicated part. We do not know what the maximum is. There are different ways we can do this, but what I'm going to do, I'm going to draw the graph first, and then you see the problem, and then we'll use our tables to figure out the best way to set it up. Okay, so let's go ahead and graph it. Yeah, you see, it's low enough, it's wide enough, but it doesn't go high enough. How high should we go? Okay, so to do this, one way to do this is to use your table. Okay, so let's press table. Second function graph will take us to table. And well, this looks terrible. This looks like a mess. So it keeps increasing. It doesn't really help us too much. We actually need to set this up in a way that actually works. So we can go back to the graph. Since the table wasn't too helpful for us, we can use the zoom function. Okay, so what we're going to do is we're going to zoom out. Okay, zoom out, enter, enter. Wow, that looks great. Now, what we're looking for is what is the maximum y value to be inputted in our window so that we have a nice little graph, okay? So if you press trace, excellent. You see, it tells us that when x is 25, you see the flashing cursor on the top right there? That is the maximum y value of 25. When x is 75, sorry, y is 25. So let's go back to our window. We're going to enter it again. So our window, we know that x minimum is the lower bound of the domain, 0. X maximum is the upper bound of the domain, 150. And then we want to scale by 5s. Remember the calculation we did earlier with the 30 tick marks. Now, y minimum is the range. The lower limit of our range is 0. Enter, because look at the graph here, it doesn't go to the negative. Think about height. You always above the ground or on the ground. You don't go on the ground when you're playing football, right? And then x maximum, what should the maximum be? We saw on the graph that 75, actually 25 was the maximum. So how about we make it a little bit bigger so we have some room? How about we enter 30? Okay, enter. Now let's take a look at what our graph looks like. Graph. Excellent. Notice how nice the graph looks. Okay, so this is what our end result is going to look like, but we are going to have to plot some points here. So what are our points going to look like? Now we're going to take a look at a table again. The table is not really helpful. Now we're going from 0 to 150. We don't have the time to do 150 input and outputs, so we want to cut it short. Okay. Now, how about we go by 30s, since we have 150 and 30 is a multiple of 150. Okay, we go by 30s. We have 30, 60, 90, 120, and then 150. That works perfectly. Not too many points. So let's see what it looks like. If we have horrible numbers here, we might try 20, we can try 40, we can try 50. Whichever one generates nice numbers, that's one we can use. But if none of them are good, we just have to estimate, okay? So to let our inputs go by 30s, starting from 0, we're going to go to table setup. You see this right here above window, table setup. So second function window gives us access to the table setup. Where are we starting from? We're starting from 0. Okay, on our tables we're talking about the x column. Now, by what value do we want our x to change? We want to go by 30s. Okay, we're going to go by 30s because we don't want to make too many tick marks. We don't have the time for that. Press enter. Now let's see what our table looks like. Second function graph takes us to table. That's excellent. You notice how nice these numbers are? We can totally graph these, can we not? So let's go ahead and graph them. Okay, so we're going to go going by 30s. Each tick mark is 5, so 6 will be equivalent to 30, since 6 times 5 is 30. Okay, so this is 1, 2, 3, 4, 5, 6. That's 30. And then we have 1, 2, 3, 4, 5, 6. That's 60. 1, 2, 3, 4, 5, 6. That's 90. 1, 2, 3, 4, 5, 6. What is that? That is 120. 1, 2, 3, 4, 5, 6. That's 150. Beautiful. Okay, now for the y-axis, we're just going to go by ones. Okay, let's just graph the points while we're at it. So for 30, we have 16. 1, 2. Well, let's check to make sure we have enough going up. We need to go as high as 25, remember? So let's count this again. If it's not, if we don't have enough tick marks going up, then we have to cut our scaling, okay? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Uh-oh. We don't have up to 25. So what are we going to do? We're going to go by twos. If you go by twos, this will be 34, which is more than enough. Okay? So we're going to go 2, 4, 6, 8, 10, 10, 12. Let's stick with the ones we need. Okay, 10, 12, 14, 16, 18, 20, 22, 24, 26. Should we go on? No, because the highest is 25. All right. Okay, so let's go ahead and graph our points. So 0, 0. 30 goes to 16. Where's 16? Right there. 30 goes to 16. 60 goes to 24. Where is 24? Right there. And then 90 goes to 24. Wow, that's nice. 90 goes to 24 right there. And then let me make sure I did this right. Yes, good. And then 120 goes back to 16. We see the symmetry happening here. 120 goes to 16. 150 back to 0. Okay? Now, where is the maximum? Remember we found that before, right? Let's take a look at the graph again. And then when we hit trace, it looks like it started at the maximum point. Okay? But to be sure that that is in fact the maximum, we're going to do a calculation here. We're going to do second function, calculate what? Maximum. Maximum, enter. It asks for left bound, a point to the left of the maximum. So you scroll your cursor to the left, press enter. Right bound, you scroll your cursor to the right of the maximum, press enter, enter, voila. So your maximum is at, when x is 74.999, that's basically 75. Y is 25, that's your maximum, okay? So where is 75? Well, this is 60, 65, 70, 75, 80, 85, 90. So 75 is right here. And then 75 takes us all the way to 25. Since this is 26 and this is 24, the middle will be 25, yes? So there goes your maximum right there. Okay, so we just connect the dots, and that will be the graph of our parabola, okay? In this problem, you don't actually have to draw the table. The graph is sufficient to give you full credit. So let's just draw the graph to the best of our ability. Pardon my horrible sketch here. So like that. This is basically what's happening with this with the ball. It goes up and then grab it, and then it starts to go right back down to the ground. Okay, looks really bad, but sorry about that. Okay, so that's the graph. All right, let's take a look at the second part. It says determine the vertex of y equals h of x, and then interpret the meaning of the vertex in the context of the problem. So if you want to find the vertex manually by using your hand, you use the formula y max. So basically, let me rewrite it. The vertex is going to be negative b over 2a parenthesis h of negative b over 2a. There goes your vertex, okay? So take a look at the function we're dealing with right here. Do you think it would be smart for us to use this formula right here to compute our vertex? It's going to be very messy, right? Do we have another choice? Do we already know what the vertex is? The answer is yes. We already calculated it with a calculator when we were looking for a maximum. What did we say the maximum value was? It was this coordinate right here. That's your vertex. Okay, so you have 75 comma 25. That's your vertex. The vertex is your max or min. All right, so we've already calculated it before. So our vertex is 75 comma 25. Okay, we did that with a calculator. Now, what is the meaning of this vertex in the context of the problem? When he kicked the ball, this is the kicker right here, the ball went up, got to its maximum height, and started to fall back down to the ground. Okay? So the vertex is basically the maximum height the ball attained, and it happened when the kicker was 75 feet away, when the ball was 75 feet away from the kicker. All right, so let's go ahead and write that down. The vertex of 7525 means what? What does it mean? It means that the ball attained its maximum height. Its maximum height of 25 feet. Remember, the y coordinate is the height, okay? Maximum height of 25 feet when it was 75 feet away from the kicker, okay? When it is 75, why am I getting my numbers mixed up? When it is 75 feet away from the kicker. Okay, so the x coordinate is how far you are from the kick, and the y coordinate is how high the ball goes. So that's the meaning. Okay, let's take a look at the last question. It says the goalpost is 10 feet high and 45 yards away from the kick. Will the ball be high enough to pass over the goalpost? Justify your answer. Now, one thing you want to recall here, something to recall, is the relationship between yards and feet. Okay, so you want to recall that 1 yard is equal to what? Is equal to 3 feet. So basically, if you want to convert yards to feet, you multiply by 3. Okay, so the goalpost is 10 feet away and 45 yards away. So if you look at this, 10 feet high, 45 yards away. What is the x and what is the y? Remember, the height is the y. We have y equals h of x. And x is how far you are, okay? So which is the x and which is the y? 10 feet high, this is your y coordinate. 45 yards away, this is your x coordinate. Okay, so so there's still some work we have to do here. We're not dealing with yards, we're dealing with feet. Okay, so what is 45 yards in feet? 45 yards is equal to 3 times 45 feet. So we have to be really careful with our units here to make sure that it's consistent. Everything is in terms of feet. So if there's another unit that's introduced, you have to convert it to the universal unit that's being used for the model and the measures in the problem. So 45 yards is 135 feet. Okay, so we have the points x coordinate 135 and y coordinate 45. If this point is anywhere below the path that the ball passes, then then you're good. If it's above, then it's no good because the ball is going to go beneath. All right. So the question now is, how high is the ball when it's 45 yards away? No, when it's 135 yards away. Okay. So let's write down the question. How high is the ball when it is 45 yards or 135 feet away from the kick? Okay, before we do the calculation with our calculator, let's see if we understand what's going on. The problem says, will the ball be high enough to pass over? So if the height of the ball when it's 135 feet away is higher than 10 feet, then you're good to go. If it's less, then it's no good. Okay, so let me just give you a visual to help you understand what's going on here. So we have this is a coordinate system, and then 45 135 yards away you have the goalpost. Okay, so this is 135 yards away, feet away, 135. Now the height of the goalpost is what? Is 10 feet. If the ball goes, if at 135 yards away, if the ball is less than 10 feet, what's going to happen? It's not going to clear the goalpost. If it's higher than 10 feet, then it's going to clear the goalpost, and it's good. Okay, so we are looking for a value that's greater than 10 in order to clear the goalpost. Okay, so let's go ahead and use our calculator to do it. So take a look at the graph. Now this is a graph. I'm going to hit trace, and I'm going to enter in 135. Just press trace and enter the number, and it automatically does it. If it's 10 or if it's greater than 10, you're good. If it's less than 10, then we have a problem. Press enter. Oh no, that's 9. That's 9 feet high. Is it going to clear the goalpost? The answer is no. Okay, so let's go ahead and justify our answer. So all we're just going to say is that when the ball, before I write my justification, how high is the ball when it is 135 feet away from the kick? Answer is the ball is what? The ball is 9 feet high. Okay, so let's answer the question. Make sure we're answering the question. It says, will the ball be high enough to pass over the goalpost? The answer is no. The ball will not be high enough to pass over the goalpost. Over the goalpost. All right, so this is your answer. This is not the justification. Justification means you state an argument. All the work we just did, how can we use that to explain why this is our answer? Okay, so let's go ahead and provide our justification. This is because when the ball is 45 yards, what is the equivalent measure of 45 yards in feet? 135 feet. Okay, when the ball is 135 feet or 45 yards away from the kick, what do we know about the height? The ball is 9 feet high, right? Which is what? Which is less than the height of the goalpost, the height of the goalpost. goalpost of 10 feet. Okay? Hence, hence what? The ball will not pass over the goalpost. The ball will not pass over the goalpost. Okay? Pass over the goal post. So that's one way of writing down your justification. There are many different ways you can write it. Just make sure you explain your thought process with the graphs and the point and coordinates. Just write in a paragraph and you should get full credit for this problem. Thanks so much for taking the time to watch this review series. It was very intense, so we want to applaud your determination to do well and your resilience. If you found this tutorial beneficial to you, please give us a thumbs up. We'll appreciate your positive feedback. Do not forget to subscribe to our channel for updates to the remainder to other New York Regents review series, the Algebra II, Geometry, Common Core review series. If you have any questions, feel free to post it in the comment section below, and we will be glad to address it as soon as possible. Don't forget to sharpen your skills with our interactive practice test. Just click on this link for access to that. All right. More clips can be found on mathgotserved.com. Thanks again for watching, and have a wonderful day.